Okay, I see it's working here. It just doesn't make sense sometimes. Okay, I see it's working here. Okay, let's just go ahead, continue from where we left off today. I might become a YouTube streamer one day, a famous one. So, we're talking about cron jobs and jobs. Um, and over here is a pod definition file named throwdice.pod.yaml is given. The image throwdice randomly returns a value between 1 and 6. 6 is considered success and all others are failure. Try deploying the pod and view the pod logs for the generated number. File is located at this path. Let's go and check. This is the YAML file. If you say kubectl get pods, right now no values are found in default namespace, but saying the image throw dice randomly returns a value between, okay, kubectl apply. Let's just go ahead and view it first. Okay, cat throw dice. All right, so we have API version v1 kind pod metadata throw dice pod spec containers image code cloud throw dice name throw dice and then restart policy never. All right, typical job, right? Well, restart policy is never. Deploying the pod. Okay, kubectl apply -f throw dice. All right. So now it's since it's deployed. If I say kubectl get pods, I have an error status. Hmm. Generator number. Okay. Kubectl. Kubectl. Describe pod, and then we have throw dice. All right. Status is failed. All right. So you want to see what did it throw? You could say kubectl log the pod name throw dice pod. It threw out one. I had to give out six, and that's why. We check the logs. Create a job using the pod definition file or from the imperative command and look at how many attempts does it take to get a 6. Use the specification command on the below. Okay, I'll go to the kubernetes.io documentation and over here in the, you can see over here in the documentation you have concepts, workloads, and within the workloads we have workload management and then we have jobs. Just copy this example and vi and I'll throw dice job.yaml. Paste the text here, and I'm gonna do a certain thing. First of all, we have API version badge v1. That's good. Kind is job metadata name. Throw dice. All right. Spec template. Spec containers. Throw dice. Um, job. I'll throw it over here as well. Throw dice job. Image. We have to change that to container. Job name is that. Image is code cloud. Throw dice. We have command. Okay, we don't need any of these commands. So delete all that. Restart policy is never. Yeah, that's part of a job. And then we can just change this to back off limit to like 25 or something. Or yeah, 25. Because the thing is like it's gonna roll a dice until it hits 6, right? Then it's a success. Otherwise, it's just going to keep restarting. So I saved that. Um, all right, so I didn't deploy it. Kubectl. Apply. F. Throw dice pod. Throw dice. Throw dice job. All right, job.batch is created. Kubectl get jobs. Running completions again. Okay, completions. Right now, you can see over here. All right, completions 1 out of 1. So kubectl describe job throw dice job. Hmm. Okay. Kubectl. All right. So you can see over here. Normal, normal, normal. Events happen. Reason successful. Create, and completed. So we had 2 pods, and then we had job completed. But you can see over here in the pod statuses, we had. All right. So it's just, I think in the first throw. Let's just check. It should be working. Monitor and wait for the job to succeed. Throughout this practice test, remember to increase the backoff limit to prevent the job from quitting before it succeeds. Check out the documentation page of the backoff limit property. Yeah, I mean, I did that. How many attempts did it take to complete the job? Well, if you look over here, um, we have 1 succeeded, 1 failed. Top odds, I think it's like 2 times. 2 times. I have a feeling this one was the right one. Hmm. So update the job definition to run as many times as required to get 2 successful 6s. Delete existing job and create a new one with the given spec. Monitor and wait for the job to succeed. So if you want to, first you have to delete the old one. So kubectl delete job, and then we have the old one. So what is called throw dice job. All right, job.batch throw dice job deleted from the default namespace. Now you want to go ahead and basically open this up. All right, so it's deleted. So I'll say vi throw dice job and update the job definition to run as many times as required to get 2. All right, parallelism, and then there was one more continuation or something, completions. So I'll just add it within the spec section. Um, I can say completions, completions, and we have 3 or 2 because we want 2 successful colon. Alrighty, so now let's apply again. Kubectl apply. How about I have job throw dice job. All right, so it should give the uh, true succeeded. I don't understand why the container throw dice image restart policy never. All right, so let's see again. Completions. DIONS. True succeeded. Job succeeded. True. Let's see again. Oh, it didn't succeed. Run again. I mean, kubectl get jobs, and then kubectl describe job throw dice job. So we have 0, 4 failed. Okay, see, once 4 failed again. 4 failed. Okay, is it like just 5 failed? 5 failed. It's just gonna keep doing it until you can see over here 1, 2, 3, 4, 5, 6. 6 of them were created. Yeah, 1, 5. So it's just gonna keep doing it until we get that result. Why is it so slow? Completions too. तो अभी completion एक ही succeed हुआ है. That's so weird, man. It takes so slow. Hmm. Compile get jobs. Egg. This is one successful out of 2 that you need, right? Hmm. So will I just delete it? Because it's pretty slow. Alright. Ah, bro. It's too slow. Kubectl delete job. Throw dice job. In job.batch, throw dice job deleted from the default namespace. After that, what I'm gonna do is I'm gonna vi, and it should delete all the pods too. So kubectl get pods. See where I throw those. Why is this one even here? So we could just say kubectl delete pod and then delete this pod as well. All right. Now let's go vi. If you go here, vi throw dice job. Name is throw dice job. Completions 2. Um, Coop cuddle. Coop cuddle. Scribe. Job. Throw dice job. Throw dice. Coop cuddle scribe. Job. Was it not created? Oh, 3 failed. Man, it's so slow. Delete the job with a typo. Coop cuddle delete the correct command. When did I do? I mean, I job with a typo. Nah, bro. One type underscore. I mean, it's pretty useful. Um, completion 2. Back off limit. This is so the job does not quit before it succeeds. Alright, so let's see now. Status. Dude, bro. Coop cuddle. Logs. And then pod. You can just go in any of these pods because they're all running a container. Right? They're all running a container. So you can see the log of the container. So it wasn't even like anything that we wanted. So what I can do is I should just say coop cuddle. We needed 6, so it's giving 4, some random number like 3. Coop cuddle, delete job, throw dice job, vi, throw dice job.yaml, and then we have this completions. We'll set this to 35, and completions is 2, and I'll also add a parallelism. I don't even know how to spell this, bro. Parallelism. Parallelism. Oh, the parallel, parallel, Parallelism, parallel, okay, parallelism, and we'll set that to 3 pods at a time. It's gonna make things faster because, alright, what the heck did I do over here? Parallel, okay, colon, escape, alright, save. Alright, so why am I in the control, was I in the control plane all the time? Alright, so, let's see now. Coop cuddle, apply, -F, throw dice job, Coop cuddle, describe, job, throw dice. Wow, that was fast. First 2 got succeeded really quickly. I don't know, bro. Sometimes it works and sometimes it doesn't. How many attempts did it take to complete this job? Well, you just had 2 successes. That was the luckiest thing ever. I was keep getting failures, and then that took a while. Let us try to speed it up. Try to write up to 3 jobs in parallel. 3 jobs in parallel. Okay. Okay. Parallel completions. Oh, should be 3. Kubectl. Delete job. Throw dice job. Kubectl. Apply or vi. Um, throw dice job. And then here we can have the completions set to 3 times we want. Why did I even write F3? Colon is. And then we're gonna have apply. And now we can have kubectl describe pod. And then we have parallelism or describe pod throw dice job. Kubectl describe pod name. Kubectl describe job throw dice job. Okay. It says over here job completed. So we had 0, 3 succeeded, 2 failed. That's awesome, bro. It got faster. Before it was not fast. Now all these pods are created. All of them got a container. Look how quickly that finished. It did. Okay, let us schedule that job to run at 21:30 hours every day. Create a cron job for this. Kubectl delete job, and then we have throw dice job. Kubectl vi throw dice job, or I can use a cron job. So vi throw dice cron job .yaml. Now, to get a cron job over here, you can see this one. This is the example. I'm just going to copy this one, and I'm just going to paste it here. Okay. So we have API version batch v1 kind cron job metadata name hello. Okay. Metadata name. Cron job name. So that's over here. Metadata. The cron job name. What is it? Throw dice cron, and then we have job like that. Job something spec. All right. Image name is code cloud throw dice. So we have container's name, image. Name will just say of the container will say as throw dice cron. This is the name of the container. And the image would be code cloud slash throw dice image pull policy if not present. I don't know what that. We don't need any of these on failure restart policy. Image pull policy. I don't think we need this. All right. Schedule. Okay, we're gonna change the schedule to basically it should work every 21, right? So these are the minutes. This is the hour, 21. And asterisk, asterisk, asterisk means every day. We're gonna apply -f cron job or throw dice cron job. Now cron job dot batch kubectl get cron jobs. Oops, what in the world is that? Kubectl get kubectl get jobs. Kubectl get cron jobs. Alright, we have a throw dice, cron job, scheduled, time zone, suspend false, active. Okay, and now let us describe it. Describe, kubectl describe, cron job, or describe job, describe cron job, throw dice, cron job. Um, I don't know. It just created it. I don't know how it's gonna run, or it's just gonna run by itself. Kubectl get pods. Okay. So it's not created anything. It's just scheduled for the future or something. Alright, so I'm gonna go ahead and move on to traffic, but right now you can see I think it's streaming, so we're just gonna give a break. So yeah, just give me a break for some time. I think we're still streaming. So yeah, I'm just gonna pause that for now. Or I'm just gonna I'm still in the stream if you guys could hear me. If you want to throw in some comments, you can. Alright, so one other thing is what I'm trying to do is trying to give out one of my um, courses on Udemy for free. Alright, so yeah, I just wanted to also add in that um, if you're interested, there's a session. There's a session of why I can't even follow this guy. Of in utilizing AI to improve your resumes and coding workflows. I'm gonna do this session on 23rd, 3 p.m. Eastern. So check that out. That's gonna be useful. I think I can have a picture of this. Let me see. Instagram post downloader. Alright, so let's see. Downloader free. Let's see. The first one I get is this one, Snap Insta. Paste the URL. You get the verifying and generating a valid access token. Close that. There's the image. Download the photo. Too many ads. And then you can just say workshop. I'm gonna add this in the YouTube post here. Thanks, Zach, Nintendo. That helps a lot. Good to see people watching. So I'm doing a live stream, so you guys can support me being a Patreon, buying me a coffee. No one has bought me a coffee ever, um, or purchasing any of my cheat sheets that I'm giving here. They're pretty cheap, and it helped me a lot to get a job and everything in tech. Like, anyways, let's go into YouTube. And I'm gonna create a post. Image. Should have like text over here. Join this upcoming workshop where I will discuss on how we can use AI to help us get jobs, tech jobs, and improve software development, software development with the help of it. Okay, I'm just gonna use some ChatGPT correct grammar. Stay logged out. Make it short and simple. So this workshop to learn how AI can help you land tech jobs and improve software development. Oh yeah, there you go. And the QR code to join the live webinar on 23rd on November 23rd, 3 p.m. 3 p.m. EST. All right, there you go. That's the post created. Also, I do have a course that I'm giving out for free right now, so I'll give it here in the chat. So Zach, if you're still watching, you get this course link. It's like 100% off. It's a course that I created on Udemy related to freelancing and how do you earn money online. All right. So just remember to enroll and leave a 5-star review. It helps out. All right, so now let's go ahead and move on to the next step. And I think we're in the traffic section.
So let us first get our networking and security basics right. And I'm sorry if this is too basic, but I just wanted to spend a minute on this to make sure we're all on the same page before we begin. We will start with a simple example of a traffic flowing through a web, app, and database server. So you have a web server serving front-end to users, an app server serving back-end APIs, and a database server. The user sends in a request to the web server at port 80. The web server then sends a request to the API server at port 5000. In the backend, the API server then fetches data from the database server at port 3306, and then sends the data back to the user. A very simple setup. So there are two types of traffic here, ingress and egress. For example, for a web server, the incoming traffic from the users is an ingress traffic, and the outgoing request to the app server is egress traffic, and that is denoted by the straight arrow. When you define ingress and egress, remember, you're only looking at the direction in which the traffic originated. The response back to the user, denoted by the dotted lines, do not really matter. Similarly, in case of the backend API server, it receives ingress traffic from the web server on port 5000 and has egress traffic to port 3306 to the database server. And from the database server's perspective, it receives ingress traffic on port 3306 from the API server. If we were to list the rules required to get this working, we would have an ingress rule that is required to accept HTTP traffic on port 80 on the web server, an egress rule to allow traffic from the web server to port 5000 on the API server, an ingress rule to accept traffic on port 5000 on the API server, and then I just wanted to. So let's just get our networking and security base user. So let us first get our get our networking and security basics right. And I'm sorry if this is too basic, but I just wanted to spend a minute on this to make sure we're all on the same page before we begin. We will start with a simple example of a traffic flowing through a web, app, and database server. So you have traffic flowing through a web, app, and database server. The traffic flowing through
Before Alright, so it's basically network policies. Network policies. Policies. Traffic. So with a simple example of traffic flowing through a web app and a database.
Through a web, app, and database server. So you have a
web app.
Flowing through a web, app, and database server.
Okay, web app, database server.
So you have a web server serving
front end to users.
Front end to users, an app server serving backend APIs, and a database server users, an app server serving
apps web server serving an app server serving
backend APIs, and a database server. The user sends in a request to the web server at port
80.
80. The web server then sends
a request to the API server at port 5000.
a request to the API server at port 5000 in the backend. The API server
then fetches data from the database server at port 3306.
And fetches data from the database server at port 3306, and then sends the data back to the user. A very simple setup. So there are two types of traffic here, ingress and egress. For example, for a web server, the incoming traffic from the users
for a web server, the incoming traffic from the users is an ingress traffic. For a web server, the incoming traffic from the users is an ingress traffic. Traffic and the outgoing.
is an ingress traffic, and the outgoing request to the app server
Outgoing request to the app server is egress traffic. And that is denoted by a straight arrow.
is egress traffic, and that is denoted by the straight arrow. When you define ingress and
Alright, I kind of get it, so I'm just going to hear this whole thing, and then we're going to respond accordingly.
And the outgoing request to the app server is an ingress traffic, and the outgoing request to the app server is egress traffic, and that is denoted by the request to the traffic from the users is an ingress traffic, and the outgoing request to the app server is egress traffic, and that is the incoming traffic and egress. For example, for a web server, the incoming traffic from the users is an For example, for a web server, the incoming traffic from the users is an
For example, for a web server, the incoming traffic from the user.
For example, for a web server, the incoming
For a web server, the incoming traffic from the user is an ingress traffic.
ingress and egress. For example, for a web server,
Incoming traffic.
the incoming traffic from the users is an ingress traffic,
Uh-huh.
and the outgoing request to the app server is egress traffic.
The outgoing goes to the app server, right?
And the outgoing request to the app server is egress traffic, and that is denoted by the straight arrow. When you define ingress and egress, remember you're only looking at the direction in which the traffic ingress and egress. Remember you're only and egress. So there are two types of traffic here: ingress and egress. For example, for a web server, the incoming traffic from the users is an ingress traffic, and the outgoing request to the app server is egress ingress traffic, and the outgoing request to the app server is egress traffic, and that is denoted by the straight arrow. When you define ingress and egress, remember you're only looking at the direction in which the traffic originated. The response back to the user, denoted by the dotted lines, do not really matter. Similarly, in case of the backend API server, it receives ingress traffic from the web server
Receives ingress traffic.
on port 5000 and has exit receiver. Similarly, in case of the backend dotted lines,
Why can't we
do
just
not really
finish this, man?
only looking
I'm basically gonna finish this, and that's gonna be the end of the session today, man. I don't know why, but we've been online for a long time today. Oh yeah, buddy. Comments on my camera, webcam. Top fans. Awesome. I don't know what this XP means. How'd you get those XP points?
at the direction. When you define ingress and egress, remember you're only looking at the direction in which the traffic originated. The response back to the user, denoted by the dotted lines, do not really matter. Similarly, in case of the backend API server, it receives ingress traffic from the web server on port 5000 and has it receives ingress traffic from the web server on port 5000
Yeah,
and has
port 5000.
egress traffic
And it has
to port 3306
okay.
to the database server. And from the database server's perspective, it receives ingress traffic on port 3306 from the API server.
Okay.
If we were to list the rules required to get this working, we would have an ingress rule that is required to accept HTTP traffic on port 80
To accept HTTP traffic on port 80.
on the web server, an egress rule to allow traffic from the web server to port 5000 on the API server, an ingress rule to accept traffic on port 5000 on the API server, and an egress rule to allow traffic to port 3306 on the database server. And finally, an ingress rule on the database server to accept traffic on port 3306. So that's the basic of traffic flow and rules. Let us now look at network security in Kubernetes. So we have a cluster with a set of nodes hosting a set of pods.
We have a cluster with a set of nodes. Hosting a set of pods.
Pods and services. Each node has an IP address.
Each node has an IP address. So does.
And so does each pod, as well as service.
Okay, cool.
One of the prerequisites for networking in
Networking in
Kubernetes is whatever solution you implement, the pods should be able to
communicate with each other without having to
configure any additional settings like routes. For example, in this network solution, all pods are on a virtual private network that spans across the nodes in the Kubernetes cluster.
Across the nodes in the Kubernetes cluster. And they can all by default reach each other using the IPs or pod names or services configured pod names or services
for that purpose. Kubernetes is configured by default with an all-allow rule that allows traffic from any pod to any other pod or services within the cluster.
Wow.
Let us now bring back our earlier discussion and see how it fits into Kubernetes. For each component in the application, we deploy a pod.
For each component in the application, we deploy a pod for the front-end web server.
One for the front-end web server. For the API server, deploy a pod. One for the front-end web server, for the API server, and one for the database. One for the front-end web server, for the API. We deploy a pod. One for the front-end.
For each component in the application, we deploy a pod. One for the front-end web server.
Component in the application, we deploy a pod. One for the front-end web server, for the API server. We deploy a pod.
For each component in the application, we deploy a pod. One for the front-end web app.
One for the front-end web server.
Web server.
For the API server. How it fits into Kubernetes. For each component in the application. Discussion and see how it fits into Kubernetes. For each component in the application,
we deploy. We deploy a pod.
We deploy a pod. One for the.
For each component in the application, we deploy a pod. key here.
A front-end web server for the API server, and one for the database. We create services to enable communication between the pods as well as to the end user. For earlier discussion and see how it fits into Kubernetes. For each component in the application, we deploy a pod, one for the front-end web server for the API server, and one for the database. We create a web server in the application, we deploy a pod, one for the front-end web server for the API server, and a pod, one for each component in the application, we deploy a pod, one for the front-end web server for the API server, and one for the database. We create services in the application, we deploy a pod, one for the front-end web server for the API server, how it fits into Kubernetes. For each component in the application, we deploy a pod, one for the front-end web server for the API server, and one for the database. For each component in the application, we deploy a pod, one for the front-end web server for the API server, and one for the database. We create server, earlier discussion and see how to any other pod or services within the cluster. Let us now bring back our earlier discussion and see how it fits into Kubernetes. For each component in the application, we deploy a pod, one for the front-end web server for the API server, and one for the database. We create services to enable communication between the pods as well as to the end user. Based on what we discussed in the previous slide, by default, all the three pods can on what we communication between the pods as well as we create services for the API server and one for the pod, one for the front-end web component in the application. We deploy a pod, one for the front-end web server for the API server, and one for the database. One for the front-end web server, the application, and see how it fits into Kubernetes. For each component in the application, we deploy a pod, one for the front-end web server for the application, and see how it fits into Kubernetes. For each component in the application, we deploy a pod, one for the front-end web server